Here's an example of the type of equations we're going to ask you to solve here in this section. It's a radical equation, and the idea is that this has a radical and that the variable that we're looking to solve for is underneath the radical. So the idea to solve this algebraically is to do some algebra here so that we get x by itself and a number on the other side of the equal sign. One way to do this is to use the property that we illustrated before. Is we can square both sides somewhere along the way to get rid of the radical. Now, a lot of students tend to get hooked up or mixed up where you immediately square both sides here. Don't do this. But what happens is if you do square both sides here, you'll get 64 on the right. But on this left side, that 2 means 2 of these multiplied together. So we would literally have something like this to deal with. Multiplying those 2 out would be an ugly, nasty chore. You'd actually have to FOIL, right? You'd have to take this, then multiply it with this, then take this and multiply it with that, then take this, multiply it with this, and then take 2 and multiply it with that. You'd get 4 expressions and it'd be ugly, and you wouldn't have gotten rid of the radical. So the idea here is don't square both sides immediately. We have to isolate the radical first. So let's do that. So the idea here is to isolate this radical expression first, then square both sides. So right now this radical expression has an adding of a 2 on the end of it. So let's do the opposite operation and subtract 2 from both sides. So we get the square root of our expression here equaling 6. And so now we can use that property we illustrated before, where to get rid of the radical we can square both sides. So here's what that looks like. So if we square both sides, that squaring undoes the radical here. And I get 36 on the right. Now this is a simple equation you should be able to solve. To get x by itself, how about add 13 to both sides, then divide by 7 on both sides. So dividing by 7 here, we get x equals 7. Now let's see what happens if we plug in this x equals 7 into here. Remember what solve means. It means find the value of x that makes both sides true. Well, the claim is 7 here. Let's just go over here and verify that here into the original equation. I'm going to plug in 7 into the original here and make sure that that actually equals 8. So I'm going to plug in 7. Let's make sure you can see that. Alright, so underneath the radical here, I get 49 minus 13 plus 2 equals 8. 49 minus 13 is 36 under there, and square root of 36 is 6. So that's true, right? 6 plus 2 equals 8. And so what we have verified for ourselves here is that this in fact is the answer that, or the value of x that makes this true. So you may be wondering why we checked our answer. Well, wait, there's more.